Hello, this is the daily message for December 23rd. So today's work is going to be split into three parts. The first part you're going to look at you're going to look at scatter plots and what's called the correlation coefficient. And what you're going to want to notice here is a scatter plot is purely a visual tool to see what happens when you plot one variable against another variable. And these plots can take many patterns, and in particular we're going to focus on when the points of a scatter plot follow a straight line pattern, and that's what we call correlation. And so you'll see information on that. And what we can see is visually when one variable goes up, another one goes up, or vice versa. What happens is when one variable goes up, another one goes down. The important thing to take away from here is just because visually it appears that one thing interacts with another one does not mean that one is causing the other one to happen. So remember back from yesterday we saw that in order to show causation you do have to have an experiment. So what you'll see is on scatter plots it can appear that two variables are interacting, but that does not necessarily mean that there's a causation. And so that will lead into the second folder for today, which is all about causation. And so how can we actually look and prove that one thing causes another? And what you're going to find is if you don't have proper experimentation, in other words, you let a confounder in. So remember yesterday we also talked about confounders. If a confounder or a lurking variable is present, then you can no longer have a claim for causation. And then finally, the last thing you're going to look at today is something a little bit different that doesn't necessarily tie in with folders 1 and 2, but does tie in with the idea of inference and why it's important for us as consumers of information to pay particular attention to inference, is what is called Simpson's paradox. And so Simpson's paradox is a phenomenon that can happen with 2x2 tables that you're going to learn about. And what you'll see is if you look at a 2x2 table, you can make one inference, and then if you take that same information and you split into two tables, your inference will dramatically change. And so you're actually going to look at two well-known examples of Simpson's paradox, one at college admissions at Berkeley and one looking at the death penalty in race. So as always, if you have any questions, feel free to use the discussion board. I'll be monitoring it to answer questions, and I will talk to you later.